everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d square plus 4 into y equals to cos 2x. Solution: given differential equation, d square plus 4 into y equals to cos 2x. Firstly, let's find the order and degree of the given equation. We can write the given equation as d square y plus 4y equals to cos 2x. We know that differential operator d equals to dy dx. Then d square can be written as d square y dx square. Right? Then this becomes d square y by dx square plus 4y equals to cos 2x. Now identify the highest derivative here. D square y by dx square is the highest derivative. So here 2 is the order. And the highest power of the highest derivative is the degree. So here degree is 1. So we are given a differential equation which is in operator form, f of d into y equals to q, right? By comparing these two, we'll get f of d equals to d square plus 4 and q equals to cos 2x, right? So we need to find the general solution to the given non-homogeneous equation using y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll get yc using roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS part to 0, you'll get the homogeneous equation and we'll find yp using f of d into q. Here you're having q of the form. Here we are having q equals to cos 2x, which is of cos ax form, right? Fine. Now let's find complementary function using the auxiliary equation. The auxiliary equation of f of m equals to 0 is, of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d square plus 4. Let's replace this differential operator by m, then you'll get f of m equals to m square plus 4. Then the auxiliary equation becomes m square plus 4 equals to 0. Right? M square plus 4 equals to 0 is our auxiliary equation. So we can find roots using this auxiliary equation in two different ways. So let's write this for 2 RHS. Let's take this 2 RHS, then you'll get m square equals to minus 4. Then m equals to plus or minus square root of minus 4, which is equals to plus or minus square root of, you can write this minus 4 as minus 1 into minus 1 into 4, which is equals to plus or minus square root of minus 1 into square root of 4. We know that square root of 4 equals to 2 and square root of minus 1 equals to I, right? Then this equals to plus or minus I into 2 or plus or minus 2I. Or write this plus as minus into minus, then you can write this as plus 4 as minus of minus 4 equals to 0. Then we know that I square equals to minus 1, right? And also 4 can be written as 2 square. Then you can write minus 1 as I square, and you can write 4 as 2 square. And we can write I square into 2 square as 2I whole square equals to 0, which is in A square minus B square form. So you can write it as A plus B into A minus B. Now equate each factor to 0. If you equate m plus 2I equals to 0, then you'll get m equals to minus 2I. If you equate m minus 2I to 0, then you'll get m equals to plus 2I, right? So we'll get m equals to minus 2I and plus 2I. That is m equals to plus or minus 2I. Imaginary roots. We know that a plus ib is a complex number, right? Then the conjugate of this is m minus ib, right? So we can call these two as complex conjugates, right? Likewise, 0 plus or minus 2i can be called as complex conjugate, because 0 plus 2i, the conjugate of this is 0 minus 2i, and the conjugate of this is 0 plus 2i. We'll change the sign, minus, right? If this is a complex number, then the conjugate of this will be 0. You'll change this minus to plus 2i, right? Since we don't have any real part, so I took it as some 0. Fine. So therefore, m equals to plus or minus 2i are complex conjugate roots of f of m equals to 0, our auxiliary equation. Now we need to write the complementary function. We know that when m equals to a plus or minus ib, then we'll write the complementary function as e power ax into c1 cos bx plus c2 sin bx, right? Then our complementary function will be y is equals to e power, we don't have any a, right? Let's write it as some 0 into x into c1 cos b. For b equals to 2, you'll get 2x plus c2 sin 2x, right? Which is e power 0 into x is e power 0 into c1 cos 2x plus c2 sin 2x, right? Which is equals to e power 0 is 1. Since e power 0 equals to 1, then we'll get y is equals to c1 cos 2x plus c2 sin 2x. Therefore, y is equals to c1 cos 2x plus c2 sin 2x. Now we need to write or find the particular integral. This is given by yp equals to 1 by f of d into q. We have f of d square plus 4 and q cos 2x, right? Now we are having f of d equals to d square plus 4, and we have q which is in cos ax form for a equals to 2. Just compare these two, we'll get a equals to 2. Okay, Now find d square. D square which is equals to minus a square. Okay. This is a formula. D square equals to minus a square is a formula for a equals to 2. Which is equals to minus, for a equals to 2 you will get minus a, that is 2 square, which is equals to minus 4. That means d square equals to minus 4. Right. So what happens if we replace this d square by minus 4? Let's see. 1 by d square plus 4 equals to 1 by, replace d square by minus 4, then you get minus 4 plus 4, which is equals to 1 by 0, which is undefined, right? So what we'll do? We won't replace d square by minus 4. Then what we have to do here? We'll write 1x into 1 by, find the derivative of d square plus 4, which means we'll find f dash of d, right? Derivative of d square is 2d plus derivative of a constant is 0, which is equals to 2d, right? So you get 2d here into cos 2x. Why? Since f dash of d is not equals to 0. Okay. Then you get x. You can just write this x into 1 by 2 into d as x by 2 into 1 by d into cos 2x. Right? Which is equals to x by 2 into 1 by d into cos 2x. We know that 1 by d is inverse of the differential operator. So here 1 by d into cos 2x, in the sense integration of cos 2x. X by 2 into integral cos 2x into dx equals to, since we know that integral cos ax dx equals to 1 by a sine ax, right? Then you'll get x by 2 into 1 by, for a equals to 2, sine ax, which is equals to x by 2 2s are 4 sine, this is 2, okay, 2x. Or you can also write this as sine x sine 2x by 4. So therefore yp equals to x sine 2x by 4, right? So we got yp equals to x sine 2x by 4. Now we can write the general solution. Therefore, the general solution is given by y equals to yc plus yp, then y equals to yc, c1 cos 2x plus c2 sin 2x plus yp, x sin 2x by 4, right? Therefore y equals to c1 cos 2x plus c2 sin 2x plus x sin 2x by 4 is the required solution. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.